We'll talk about how to affect the conductivity of metals. So first, if you lower the temperature, spell that right. Of a lattice. So the lattice, there are very few lattice vibrations. So an electron is free to move without very much impedance. And that leads to low resistance, which leads to high conductivity. And if you raise the temperature, of a lattice, the lattice looks more like this, with a lot of lattice vibrations. So when an electron moves through, it has a high impedance, which leads to a high resistance, which leads to low conductivity. Another way to affect conductivity of metals is through impurities and defects. One kind is to have a missing atom in a lattice. So when a lattice would originally look like this, let's say, it now becomes more like and these four atoms want to fill in the gap. So they become something like this. So now when an electron moves through this, there was a relatively low resistance and high conductivity, but now if an electron wants to move through here, there's now a low conductivity. Another type would be if another element is added in a hole. So if you have a lattice that looks like this, you have another element that's added here. So just in this example, an electron would originally have been able to move through with a low resistance and a high conductivity. Now it wants to move there, and it encounters high resistance and low conductivity. And again, this is adding a different element in a hole. Another type would be adding a different element in a lattice site. So something that would be a bigger element. So if this atom were small like these, that the electron would be able to move through. But since it's bigger, the electron encounters impedance and a low conductivity.